We have finished up 9.1. And instead of going to 9.2, which was my original goal, I'm already getting the deer in the headlight look. And so I have decided, because all we have left is 9.2, 10.1, 10.2, 10.3. And they're really not that bad. And we have all of next week just to do 4 sections. So, what I'm gonna do, we did some review for 7 and 8 on Monday. So if you were not here last time, you're gonna wanna go back and look at that review. Go over those questions, look at the notes. But I'm gonna do a little more review today because I'm telling you for that 7 and 8, you just need to practice all the different types of problems. So instead of going to 9.2 today, I'm going to do some more practice. So, this is going to be more of a review for 7 and 8. The test is due on Monday. All right, for this first one, 24%, and I just quickly wrote them while we were on the break, so it's not the best handwriting. 24% of cars purchased last year. If a sample of 600 were sold last year, what is the probability that between 125 and 300 are sold? Okay, so if we were doing this problem, what would we do besides skip it? Do y'all want to try it first? Or do you want to work it together? Do y'all even know where to start? Tell me what you want me to do.
Might as well do it together.
All right, tell me where that 24% is going to go.
Hold on, I have a quick question. What is that B/T?
Between.
Oh, okay.
Between.
Yeah.
Okay, it says what is the probability? So what are we trying to find, y'all? Percent probability, the shade. So we're trying to find the shade. We get that from the problem at least. So that means we're doing this kind of problem and we're trying to find the shade. So what kind of problem is this if we're doing it in our calculator, we're trying to find the shade? Normal CDF. Okay. Now, from that problem, do y'all see the mean? It's there. 0.24. This is my mean. 0.24. All right? Now, because we have a percentage on the bottom, that means we need all percentages on the bottom. Very good. So we're going to do 125 over 300, and 600, thank you. And we're going to do 300 over 600. Because we can't just put 125 and 300 because they're not percentages. That 24 was a percent. So everything else has to be a percent. So I'm going to go to my calculator and I'm going to do 125 over 600 and 300 over 600. So my two percentages are going to be like 0.2083 and 0.5. So the 2083 and the 0.5. The 2083 is going to be somewhere to the left of 24%, and the 0.5 is going to be somewhere to the right. Are you with me? And we want to know the between. So I want to know this. Now, when I do normal CDF, I do, where does the shade begin, where does the shade end, what is my mean, and what is my standard deviation? Where did my shade begin? 0.2083. Where did my shade end? 0.5. What is my mean?
0.24.
0.24. Do I know my standard deviation? No. How do I find my standard deviation of a percent problem? My standard deviation is the square root of P love you. It is P, 1 minus P over N. What is my P?
0.24.
So it's going to be 0.24, 1 minus 0.24 over N. N is what in this problem? 600. How many people I sampled? So in my calculator, it is going to be 0.24, parentheses, 1 minus 0.24, and this is where I would do, like I told Austin a minute ago, I would get my answer, then I would divide by 600, then I would take the square root of that answer. Now, what I just found was just the new standard deviation. 0.017435559, blah, blah, blah. So 0.01743555958. So now I'm going to do the normal CDF of that. So I'm going to do second VAR's normal CDF of 0.2083, comma, 0.5, comma, 0.24, comma, 0.017355958. That represents the area under the curve. And your answers are going to be multiple choice, so you don't have to worry about where to round it to. This is a quote-unquote P problem. Did hit start, didn't I?
Yeah, it's recording.
Okay, thank you. Because I want them to redo that problem. All right, let's look at another one. The amount of M&Ms in a 24-ounce bag has a normal distribution with a mean of 17.5 and a standard deviation of 0.3. What M&M has the 64th percentile for the bag weight distribution? Are y'all feeling froggy about this one? Or do you want me to do it? An amount of M&Ms in a 24-ounce bag has a normal distribution with a mean of 17.5 and a standard deviation of 0.3. What M&M has the 64th percentile for the bag weight distribution? Am I doing it or y'all doing it? Yes, I'm doing it. We have a normal distribution. Do we know our mean?
17.5.
Yes, this time it said the mean is, so y'all know it, 17.5. What is my standard deviation?
0.3.
0.3. What does 64th percentile mean?
That means the shading.
The shading. So 64th percentile is telling you the shade. Is that the shade to the left or the shade to the right?
Left to the left.
That is the shade to the left. Remember, if Madison's head was in the 64th, That is the people whose heads are lower than hers, okay? So that's the shade to the left. So the 64th means there are 64% below you. So all of that is 0.64. I want to know what M&M. So what am I trying to find out?
C.
The z-score. What M&M? So I am trying to find out the z-score. So what am I going to do for this problem?
Inverse.
The inverse norm. And when you do the inverse norm, you are doing the area to the left, comma, the mean, comma, the standard deviation. Do I need to redo the standard deviation?
No.
No. The reason I don't need to redo the standard deviation is because I'm talking about one M&M. I'm doing a picture of one M&M. I'm not doing a picture of 45 M&Ms. It doesn't say, put 45 M&Ms in there. Do a sample of, you're doing one M&M. So what is my area to the left?
17.61.
My area to the left.
0.64.
yeah.
0.64. What's my mean?
17.2.
17.5. What's my standard deviation? 0.3. And I'm doing inverse norm because I am getting the z-score. I'm getting the point. So I'm going to do second bars. I'm going to do inverse norm of 0.64, 17.5, and 0.3. So that is telling me that that little M&M is going to be a 17.6. That specific M&M, Josh, we're just doing a review for the test. That specific M&M is a 17.6 z-score. Yay? If the population proportion is believed to be 0.4, how many items must be sampled to ensure that the sampling distribution of p hat is approximately normal? If the population proportion is believed to be 0.4, how many items must be sampled
I want to say at least 30, but I don't know if that's relative.
It is at least 30 to be approximately normal. If it was like the normal sampling, but Sharon is really good at this. If it's a P problem, what has to happen if it's a P problem for it to be approximately normal?
This is that P must be less than N, or
Give it to me.
N is less than or equal to 0.05 big N.
And
N times P times 1 minus P must be greater than or equal to 10.
okay. Now, for this problem, it says how many items must be sampled. So what are we trying to find? We're trying to find N. Now, in this problem, do we know that? No. So we can't use that one. Here, we know that we're trying to find that. Do we know this one?
0.4.
Do we know this one? 0.4? So I can't use this one because I don't know it. This is what I'm trying to find. And both of these are going to be 0.4. So it's going to be N times 0.4 times 1 minus 0.4. So it's N times 0.4 times 0.6 because 1 minus 0.4 is the same thing as 0.6. 0.4 times 0.6, I'm gonna clean up in my calculator first, is 0.24. And what do I need to do to both sides to get n alone? Divide by 0.24. I'll not that equal there. Cancel, cancel. So it's gonna be 10 divided by 0.24. So how many pieces of data do I need to have? 42 pieces of data. So because it's a p-hat problem, because it's a proportion problem, both of those things need to happen in order to be approximately normal. If it was just a sampling problem without the proportion, then we would just say, oh, it has to have at least 30.
So this means they would have to have at least 42?
42 people would have to be asked in the survey or more
Okay.
for the picture to be approximately normal.
Got it.
All right, let me slide this bad boy down a little bit. We have a normal distribution with a mean of 7 and a standard deviation of 2. Find the probability that it is less than 4.5. I should be able to do this one. Normal distribution with a mean of 7, a standard deviation of 2. Find the probability that it is less than 4.5.
So this would be, we would be looking for like the shading in the left tail.
Find the probability. That means find the shading. Find the probability, find the percent, find the shade. So it's going to be a normal CDF. When we do normal CDF, it's where does the shade begin? Where does the shade end? So we began at negative 9999. We ended at 4.5. My mean is 7 and my standard deviation is 2. So it's going to be a normal CDF because we're doing the shade. It began at negative 99999. I think I put one too many nines, but that's okay. It ended at 4.5. My mean is 7. My standard deviation is 2. So that means my area under the curve is about 10.5%. Is that what y'all got? Sure you did. And the good news is, all your answers are multiple choice. So at least you have something to choose from.
When do we use the PDF again, or do we not?
For this, you're only doing
It's just CDF?
CDF and inverse norm. We go with that one? Or review them for the test? All right. See what y'all can do with this one. We have a distribution with a mean of 4.3. I moved it up a little bit too far. I didn't grab everything. Hold on. It is a distribution with a mean of 4.3 and a standard deviation of 7. You have a random sample of 100 and the mean was calculated. Describe the mean. For example, tell me about the shape. Give me the new mean and the new standard deviation. So, is it approximately normal or not? Which means run that test on it. And tell me what the new mean is and what the new standard deviation is. So, is it approximately normal? And what is the new mean and what is the new standard deviation? So, I'm just telling you it's a distribution. I don't know if it's normal or not. Just a second. I'll pull it back up in just a second. I'll show you something. All right, here's a reminder. These are the easy breezy problems. The mean is the mean, the standard deviation is the standard deviation. If it's talking about a sample size, a sample of 100, a sample of 36, a sample of 25, the mean is the mean. The standard deviation is going to be the old standard deviation divided by the square root of the size of the group. So if it's talking about a sample size of 25, a sample size of 100, that's when you do your standard deviation divided by the square root of the size of the sample. And your test to see if it's normal is going to be if it's greater than or equal to 30. That's your test to see if it's normal. The p, if it has a p in it, your mean is your p. Your standard deviation is going to be the square root of p, 1 minus p over n. And to tell if it's normal is going to be these two tests. So either you have straight up, the mean is this, the standard deviation is this, get to work. Or you're going to have the mean is this, the standard deviation is this, and I have a sample size of this. Then your mean is going to be your mean, and your standard deviation is going to be divided by the size of the square root of the group. And you're going to tell me whether it's normal or not by saying, is your group bigger than 30? If it has a p in it, a percent, your mean is going to be your percent. Your standard deviation is going to be your percent times 1 minus your percent divided by the square root of the size of the sample, and take the square root. And then these two tests are going to tell me whether it's normal or not. So those are the three types of problems. I know, James. I know, boo-boo. We got this. That's why I didn't go on to 9.2, because y'all were giving me that death look. That deer in the headlights look. So this one is a straight up. The mean is this, the standard deviation is this, work it out. This one is the mean is this, the standard deviation is this, here's the size of the group. You've got to divide by the square root of the size of the group to get your new standard deviation, and if I ask you, is it normal? Is it approximately normal? All you've got to do is say, how big was the people that you were asking? If they're bigger than 30, then yes, it's approximately normal. Then if it talks about a percentage, then your mean is going to be your percentage. Your standard deviation is going to be your percentage times 1 minus your percentage divided by the size of the sample, take the square root. And if I say, is it normal, you've got to do these two things to tell me if it's normal. Those are the 3 types of problems.
What does SEM mean?
Standard error of,
Margin?
no. Crap, I just had it on my, because you have
It
to know
was
that.
up there a little bit. You
Did I go
scrolled over
past
it.
it?
Yeah.
Standard error of the mean.
Oh, okay.
Standard error of the mean. And when I ask you for standard error of the mean, and there's a question on the test, hint, hint, if it says find the standard error of the mean, all it wants to know is the new standard deviation.
Okay, so standard deviation divided by the square root of the sample size.
Yes,
Okay.
that's your new standard deviation, is the standard error of the mean. Standard error of the mean. And I can even, let me snag this, copy, and let me, where am I? I'm not doing that today, I'm not doing 10-1 today. Let me put this at the end of the notes. And I even, not that page, I'll get this page. All right, so let's go back and look at where I was. So for like this one, because this had a percent in it, that was that last type of problem. That's why our percent was our mean. Okay? That's why we had to turn these two into percents, because we can only have percents here. And we did the shading. We did, where does the shading begin? Where does the shading end? What is our mean? And this is why our standard deviation, was the P1 minus P over N. Because it was that last type of problem that your standard deviation was the P1 minus P over N. Y'all with me? Because it's the P problem. This was that number 1 that we did.
Oh, okay.
That number 1.
Got it.
Yeah. This one wasn't a P problem, it was straight up. This is your mean, this is your standard deviation. This was a straight out, the very first type of problem. This is your mean, this is your standard deviation. That was a straight up type of problem. This one talked about P. So that was that third type of problem. And it's, tell me about, is it a normal distribution? So it was that very last thing. Is it normal? What are those 2 types of things for P being normal? Those are those 2 rules that you have to memorize. This is the mean, this is the standard deviation. That was a straight up the first type of problem. Okay, so now let's come to this one. We have a distribution with a mean and a standard deviation and a random sample. So are we talking about the first type of problem, the middle type of problem, or the last type of problem? The middle type of problem. the one that talked about sampling. Now, describe the mean. So in that middle type of problem, the mean is the mean. So what is the mean?
4.3.
So the mean never changes. The mean is the mean is the mean is 4.3. Tell me about the standard deviation.
We have to
The
change.
old